Hey guys, let us continue the previous numerical based on the method of joints. Now consider joint E, where there will be three forces acting on it, that is force FAE, which is already found out to be 16.66, force FEF and force FBE. Now applying the equilibrium conditions, we have summation H is equal to 0. Hence minus 16.66 plus FEF will be equal to 0. Hence we get the value of FEF to be 16.66 kilonewtons. Hence the force will be a tension force. Now summation V is equal to 0. Since there is only one vertical force, that is FBE here, we come to know that this force FBE will be equal to 0. Now consider joint B. Here we have the 20 kilonewton force acting at the point B, force FAB, that is nothing but 23.57 kilonewtons, force FBF and force FBC. Now applying the equilibrium conditions, we have summation H is equal to 23.57 cos 45, that is the horizontal component of this force, plus FBC plus FBF cos 45, that is the horizontal component of the force FBF, to be equal to 0. Hence we have FBC plus 0.7071 FBF to be equal to 16.66. Now consider the condition summation V is equal to 0. Hence we have 23.57 sin 45 minus FBF sin 45 minus 20 is equal to 0. Hence we get the value of FBF to be minus 4.714 kilonewtons. Hence this will be in compression. Now substituting the value of FBF in this equation and solving, we get the value of FBC to be minus 13.33 kilonewtons, which will be also in compression. Now consider the joint C. Here the 10 kilonewton force will be acting downwards, and also FBF, that is 13.33, FCD and FCF will be acting on the point C. Now summation H is equal to 0 implies FCD cos 45 plus 13.33 will be equal to 0. Hence we get the value of FCD to be minus 18.856 kilonewtons. Hence the force will be a compression force. Similarly, summation V is equal to 0 implies minus 10 minus FCF minus FCD sin 45 will be equal to 0. Hence we get the value of FCF to be 3.333 kilonewtons, which is a tensile force. Now coming to joint F. Here we have force FEF, that is 16.67, force FFB, that is 4.714, force FFC, that is 3.33, and force FFD, which will be acting on the point F. Hence applying the condition summation H is equal to 0, we have FFD minus 16.66 plus 4.714 cos 45 to be equal to 0. Hence we get the value of FFD to be 13.33 kilonewtons, which is a tensile force. Hence now we have found out all the values of the required forces at the different joints. Hence making a tabular column, we have the members, the magnitude of force for each member, and the nature of the force, that is whether it is in tension or compression. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magaz videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.